Hello, and in this video we're going to talk about simple probability. In chapter 3 we're going to talk about complements, mutually exclusive and independent. The definition of a probability of an event occurring is given by P with whatever that event is. In parentheses, that's going to be equal to the total count that event occurs in the numerator and the total count of the sample space in the denominator. That's all of the events listed in that can occur. So we just divide those two numbers and that's going to be our probability, and that's simple probability. If we're going to do combinations of probability, we may see the word or. Okay, so if you see the word or, if we say two events, one or the other occurs, that means that you're going to count everything in A and everything in B together, but you're not going to count things twice. Okay, so if A was the numbers 1 through 5 and B is the numbers 4 through 8, you're going to end up with A or B being the numbers 1 through 8, but you're not going to list 4 and 5 twice, because it just 4 happens and 5 happens, but we don't have to list them twice. They don't occur twice. We're just doing one event here. So or looks like that. If we say an or in between two events. If we say and in between the two events, that means that we're looking for overlap. That means something that's in A and in B. So in this case, if A is 1, 2, 3, 4, 5 and B is 4, 5, 6, 7, 8, then A and B would just be 4 and 5 because that's the overlapping portion. So A and B is 4 and 5 there. Now the other part of this is you can see that you're going to want to know what a complement of an event is. Well, a complement is everything that's not in the event. So it's denoted with a prime here. So if you see a letter with a prime, that means complement. That means that we're going to do everything that's not in the event, not in the list. Okay? So that means that the event itself plus its complement is always going to be 100% or 1. Okay, so if we let the sample space be the numbers 1 through 6 and A is 1 through 4, then the complement would be 5 and 6 because that's not in A, but it's in the whole sample space. The probability of A is 4 out of 6. The probability of A complement would be 2 out of 6, and if you add those together you get 1 or 100%. Okay, so those things can happen when we're dealing with probability. You're going to deal with and events, or events, complements of the event, and you're also going to be dealing with conditional probability. That means that if something's already occurred. All right, so this is written as P of A given B. That's how we read it. P of A given B, with a slash means the word given. That means that B has already occurred, and so that's going to be our denominator for the probability of B occurring. Now the top is going to be A and B. That's when they do A and B together. That'll be our numerator part. Okay? So if we were doing the sample space of 1 through 6, as this example says in the book, and we let A be 2 or 3, and B be evens 2, 4, 6. If we want to do A given B, that means we've already done 2, 4, and 6. We've counted 2, 4, and 6. That's now our denominator, right? So we would only end up with 3 in our denominator because you only have 3 in the sample space, and you'd end up with 2 or just actually 2. Because 2 is the only one in that list, so it'd be 1 out of 3 as your probability there. Okay, so 1, 2 is the only number in this sample space of B. Say when we're doing A given B, so B has already occurred, that means we only have 3 left in the sample space. Okay, so the formula would be 1/3 for that, the probability. Okay, and they show that here by dividing. But I just talked about how we reduce the numerator by just taking the how many is in sample B and using that as our new denominator. Okay. Now the other thing that we're going to be doing in this thing besides simple, and so we talked about simple, we talked about complements, we're also going to deal with mutually exclusive and independent samples. All right, so let's get to those definitions. Okay. So an independent event is when the conditional event and the regular event are the same probability. So if we are doing P of A given B, that means if we are doing a subset of A, we're still going to get the same probabilities if we did it in the regular whole sample set. So if those two probabilities are the same, then the two events are independent. We can also say if we do the AND portion, P of A and B, that's going to be the same as the multiplication of P of A and P of B. If that multiplication is the same as an AND, then that's how we check it. But usually we just check it this way with a conditional. We run a conditional and we run the normal and see if those fractions are the same. Okay. Now usually when we do things with replacement, then those are going to be independent. So that means we put the things back in. So if we're drawing numbers out of a jar and we put the numbers back in, that's going to be independent. But if you pull something out and then you don't put it back in, then those second picks or whatever we choose out of the jar after the first pick is going to be dependent on what we drew out of the first time. So their probabilities are not going to be the same. Okay, so that's what independent means. All right, now if we're going to do mutually exclusive means that they cannot occur at the same time. That means the probability of A and the probability of B together, A and B, is 0. There's no overlap in there. Okay, so A and B here are not mutually exclusive because they share 4 and 5. There's overlap. Okay? If we look at A, 1 through 5, and C, 7 and 9, those are going to be mutually exclusive. B and C are not mutually exclusive because they share the 7 value. Okay, so mutually exclusive would be something where there's no overlap in the sample spaces, in the subset spaces for A, B, and C. All right, let's take a look at some of your homework from this section. Okay, so question 3 here, it says a bag of M&Ms have 2 red, 5 green, 4 blue, and 7 yellow. So that means you have 18 M&Ms. So 18 would be your denominator for your probability because that's your whole sample space. You have 18. So the probability of yellow would be 7 out of 18. So if we took our calculator, because they're wanting a decimal here to 4 places, we just do 7 divided by 18, and we would use that decimal here. So we would round up. This one would be 0.3889 rounded up on the 4th decimal place. Okay, blue or green, meaning we would take the blue and green ones, combine them, so that would be 9 out of 18. 9 divided by 18. That would be 1/2 or 0.5. You don't have to round that one, or you don't have to put 4 decimal places at. And orange, we don't have any orange, so that would be 0. We don't have any, so that would be 0 oranges out of 18 M&Ms. There are no orange ones. Okay, so those would be the solutions to that question. All right, let's move down a little bit further and do an OR and an AND. Okay, so if we look at this one here, and it says we're drawing a diamond or a heart. Well, there are 13 hearts and 13 diamonds. If you look at that, that's going to be 26 out of 52 cards, because that's half of them, right? So that is the answer, half, or 0.5 for that one there, because half the cards are either hearts or diamonds. But if not, you would divide that number by 52, and that would be your answer. In this case, 26 divided by 52. Okay. Let's go down a little bit further. So in this one, it says probability that you have a number greater than 9. So that would be 10, 11, and 12. That would be 3 out of 12. So if you divide 3 by 12, I know what that is, but 3 divided by 12 is 0.25. That would be your number that goes here, 0.25. Because there's 3 out of 12 if you spin once. Okay, let's look down here. Now we're just trying a few of these. Okay, so this last one, this one talks about being mutually exclusive. So if they're mutually exclusive, that means that the probability of U and V is equal to 0. So what we know on this one is that we know that P of U, for this problem, P of U and V is going to equal 0 because it says it's mutually exclusive. We know P of U equals 0.28 and P of V equals 0.54. So if we're going to do these things, we're going to use formulas. So U and V, the probability of U and V, since that one we would know because we just said that right here, right? Because we know they're mutually exclusive, so this would be 0. Right? I don't have to do any work. I know that that's true by definition of mutually exclusive. Now, the probability of U given V, if we use the formula that was given to us for conditional probability, if not, you need to go back and look it up, but it's P of U given V is equal to P of U and V over P of V. Well, P of U and V, we know that's 0, so it's 0 over the probability of V, so it's 0 over 0.54, which is still 0, right? And then, or, since they're mutually exclusive, the P of U or V is going to be the probability of U plus the probability of V. Because it's mutually exclusive, there's no overlap, so we don't have to worry about overlap here. If there was overlap, if it's not mutually exclusive, then the probability of U or V is given to the probability of U plus the probability of V minus the probability of U and V. So this is given if it's not mutually exclusive. If it's mutually exclusive, this is 0, so it doesn't matter. Okay, so we're just going to add these two probabilities together to get our answer here. Okay, so that's 12, so that's 0.82 for this one. Okay, and let's check, because I can check. So this should be 0, that's what it says. This one should be 0, but that's what it says. This should be, oops, 0.82, because you add those two together. And that's what it is. Okay, so we check that answer. So that's the first part of chapter 3. Okay, so make sure that if you don't have these notes, then make sure that you go to the end of chapter 3 and review the key terms that we just talked about, right? Conditional probability, independent, dependent. It has the formulas right there. Mutually exclusive gives you formulas. Sample space talks about all of the things we just talked about, and it gives you formulas here, right? Here's the conditional probability. Here's the complement one. Here's this one. It kind of runs together here. This is a bad formatting here. This is A and B equals probability A times the probability B, right? So it's supposed to go these two multiplied together, but they really bad formatting there. Okay, so that's not the greatest in that spot. Okay, all right, but they're in the back of the section if you go there.